Hello, dear students. Today we shall understand some of the problems that are based on the rate of reaction or the order of the reaction. So let's start. Let's look at the question first. The conversion of molecules X to Y follows second order kinetics. If the concentration of X is increased to 3 times, how will it affect the rate of formation of Y? So here we have the reaction X that is converted into Y. Ultimately, the rate of reaction is equal to minus d by dx by dt is equal to dy by dt. So your rate of X is equal to rate of formation of Y. This is rate of disappearance of X. This is rate of formation of Y. According to the rate law and the statement X converted to Y follows second order reaction, we can simply write rate of reaction is equal to K into X to the power 2. So ultimately we can write minus dx by dt is equal to dy by dt is equal to K into X to the power 2. Therefore, dy by dt is equal to K into X to the power 2. It means that the rate of appearance of Y is equal to K into the X to the power 2. This is what we can simply write or simply understand. Now the concentration of X is increased 3 times. So the new concentration Xn is equal to 3x. So the new rate of appearance of Y dyn by dt is equal to K xn whole square, that is K into 3x whole square. It simply means dyn by dt is equal to K into 9x square, that is simply 9 into K into x whole square. But K into x whole square, here from here itself we can say that it is dy by dt. So here we can write K into x whole square is dy by dt. So dy nu by dt is equal to 9 times dy by dt. So ultimately what we can write here is that the new rate of formation of Y is 9 times the old rate. So the rate is increased by 9 times. This is what we can simply understand. Now we want to understand about the unit of rate constant. So according to the law of mass action, rate is equal to K into a to the power x b to the power y. For the reaction A mole of A plus B mole of B, that gives C mole of C plus D mole of D. And we know that X plus Y is equal to N, that is the order of the reaction, and X plus Y may or may not be equal to A plus B. So here we can write that from this equation we can write that K is equal to rate divided by A to the power X into B to the power Y. But rate this rate divided by mole per liter to the power X plus Y, because the square bracket represents the mole per liter concentration. Therefore we write rate divided by mole per liter to the power n, because x plus y is equal to n, and n is the order of the reaction. So ultimately what we can write, rate is equal to mole per liter sorry rate is equal to mole per liter per time, that is the concentration per time. That is, this is how we can write, it is concentration per time divided by concentration to the power n, because mole per liter to the power n. So that is how we can write mole per liter to the power 1 minus n, because n from the denominator, if it goes to the numerator, then the power is minus per time. So now we can, if we take this time in seconds, so we can get the exact idea what we should get. So now it is clearly written. Now if we take time in second, then the unit of K should be mole per liter to the power 1 minus n divided by second, that is mole per liter to the power 1 minus n second inverse. Here n is the order of the reaction. So now for the various order, let us try to understand the unit of rate constant. If your order is 0, that is your n is equal to 0, so unit of rate constant is mole per liter to the 1 minus n second inverse 1 minus n is equal to 0, so it is 1 minus 0, that is 1. And finally the unit of rate is mole per liter per second. Now if you have first order reaction, then you have mole per liter into 1 minus n power second inverse, but here n is equal to 1, so it is 1 minus 1 mole per liter to the power 1 minus 1, that is 0. So anything to the power 0 is 1, and ultimately the unit is second inverse. If you have n is equal to 2, that is your second order reaction, so you will have mole per liter to the power 1 minus 2, because n is equal to 2, that is what it is, mole per liter to the power minus 1 per second, that is equal to mole per mole, like mole inverse liter, not liter to the power 1 and second inverse. Same way for the third order reaction, we can write mole per liter to the power 1 minus 3 second inverse. If we simply convert it, it will be mole to the power minus 2, liter to the power 2 and second to the power minus 1. Same way, if you have the nth order, we can write mole per liter to the power 1 minus n second inverse. So this is how we can easily find out the unit for rate constant easily. Now we should solve some problems based on this, so that we can easily understand the rest of the part of the problem.